Hello, calculus fans. We're going to consider a different version of the chain rule now. This is the situation where z is equal to f of xy. But now, each of x and y is themselves a function of two variables, s and t. We'll say that x is equal to g of st and y is equal to h of st. So previously, x and y were considered to just be functions of a single independent variable t. Now we're going to have two independent variables s and t. This is a fairly common situation. So we'll say that z is indirectly a function of the two independent variables s and t, and our goal will be to compute dz by ds and dz by dt. These are now partial derivatives because we're thinking of z as being functions of more than one variable. Now remember that when we compute dz by dt, we'll pretend that s is a constant and then compute the ordinary derivative of s with respect to t. So when we do that, we can apply the first case of the chain rule, and this is what we'll get. We'll get dz by dt is equal to dz by dx, dx by dt, plus dz by dy, dy by dt. And we can have a similar argument for computing an expression for dz by ds. And so what we get now is this version of the chain rule. So this is the second case of the chain rule. The difference now, again, being that x and y are each functions of two independent variables. All right, so now what we have is case 2 of the chain rule. This says that suppose that z is equal to f of xy is a differentiable function of x and y, and then x is equal to g of st and y is equal to h of st. Those are going to be differentiable functions of s and t. Then dz by ds will be equal to dz by dx, dx by ds, plus dz by dy, dy by ds. And a very similar thing for dz by dt. So this looks a lot like the chain rule that we talked about before, except now there are no more ordinary derivatives in here because everything that you see is a function of more than one variable. Okay, that's all for now.